Okay, so for this one, I have factored the denominator when I brought it over, so I needed it to multiply to 16 and add to be 8, so that'd be x plus 4, and then writing it over here is squared, just as a shorthand. So we need to find our asymptotes and our x and y intercepts. Okay, so our vertical asymptotes are going to be from our zeros in the denominator, and so that would be a negative 4. Our horizontal asymptote, so that comes from our small over big, the degree of the numerator and the degree of the denominator. So remember, if the degree of the numerator is smaller than the degree of the denominator, which in this case it is, that is always y equals 0. And that's because it would reduce to 1 over x, and 1 divided by really large numbers ends up being really close to 0. So that's why anything, as long as, if this was x cubed down here and this was x to the 5th, that would be y equals 0 every time this is smaller than that. And then, so the denominator of the rational function gives us vertical asymptotes. The numerator of the function gives us x-intercepts. So here, to find an x-intercept, I would let y equal 0. And the reason I don't need to worry about the denominator is because the first thing I would do here, if I did worry about the denominator, is I would multiply both sides to clear it. And then it would still be 0 on this side, and it ends up equaling the numerator every time. So the denominator gives you your vertical asymptotes, the numerator, the zeros of your numerator, give you your x-intercepts. So that's the difference between those two zeros. So here we ended up with x equals 0. Okay, so when y was 0, x was 0. So in that case, and this is the one and only case where the x and y intercepts are the same thing, because now if I went to find the y-intercept, I would let x equal 0, and I would have 0 divided by 16 is still 0. So in this case, that counts as both an x-intercept and a y-intercept. And so that would be it in terms of the features of the graph, and then we just have to figure out which one it is. So we know we have a vertical asymptote at negative 4, so no, that one's possible, no, and that one's possible. And then we know we have an asymptote at 0, and we have an intercept at 0. And so in this case, our horizontal asymptote is being crossed, and that can happen. So then we have the question of, is it this graph or that graph? And then also let me just point out, since we have these two graphs, notice that in both cases, that as we approach the vertical asymptote here, the graph is going the same direction on both sides. So in this case, it's both going to negative infinity. In this case, it's both going to positive infinity. And that's going to be because of that squared. So then what we got to figure out is when it is, I would pick an easy number, like maybe negative 3 looks pretty good to me. I would throw a negative 3 in here, and then if it comes up to be a negative value, that makes it this graph. If it comes up to be a positive value, that's going to make it that graph. So let's see what happens. So we'll do f of negative 3, and I get the negative of negative 3 divided by negative 3 plus 4 squared. So negative of negative 3 would be 3, and then negative 3 plus 4 would be 1 squared would be 1. So it looks like when x is negative 3, the y on that would be 3. So then that helps me figure out that it must be this one right here. So I think that was all the pieces on that. Cool, hopefully that helps.